All right, we're moving on to hydrocarbon derivatives. So this will be new. Okay, a lot of it though, if you understand how to name the first three groups, okay, then you're just going to be adding different prefixes on and suffixes and so on. Okay, so we call these functional groups. So a functional group, okay, is how we classify organic compounds. Okay, and so like if it has a double bond, the functional group would be an alkene. If it has a triple bond, alkyne. Okay, so functional group is just special arrangement of atoms that is mainly responsible for the chemical behavior of the molecule. Functional groups also determine some of the physical properties of the molecule. And so here's kind of the main functional groups we have to know this year. So we've already gone over alkenes and alkynes. Okay, next is alcohols. Okay, so alcohols, their suffix becomes OL. Okay, they have the hydroxyl group coming off one of the carbons, which is an OH group. Okay, an example, so propan 2 also. Similar to where we have to say where the double or triple bond is, we have to say where this alcohol is coming off, like where the hydroxyl group is coming off. Okay, the alkyl halides, this just means there's going to be a halogen coming off. Okay, and the prefix will have a halogen, so like this one here, 2-chlorobutane. So the halogen would be chlorine, okay, coming off the second carbon. Okay, and so like, yeah, X just represents any halogen. Again, the halogens, chlorine, fluorine, bromine, and iodine. Okay, carboxylic acids are the next functional group. Okay, and so they end in oic acid for their suffix. Okay, and then their group, it's on the end carbon, will have a double bonded O, and then single bond to an O, which is then bonded to an H. Okay, this is called the carboxyl group. We'll go into them more. Okay, and so again, like you count up, so we have 3 carbons, 1, 2, 3. So it's propan, and they're all single bonded, so we get the AN. Okay, and then propanoic acid. Okay, and then esters, they end in O8 for their suffix. Okay, basically an ester, you take off this H and you bond it to another carbon chain. Okay, and then we'll talk about these. Again, we're going to go through each of these and how to name them and draw them and so on. All right, let's move on. Okay, so starting with alkyl halides, these are probably the easiest because they're basically the same as naming like different branches and groups that come off the main chain. So alkyl halides are hydrocarbons that contain at least one halogen atom. They're not found in living systems, but are artificial. So when we're naming them, okay, like alkyl, did we already? Oh, okay. Basically, alkyl halides are named according to the parent alkane. So identify the root, so the longest chain that includes the halogen atom. Okay, so similar to like alkenes. Okay, identify the prefix. So what is the number that the nearest to the halogen atom? If the compound is a cycloalkane, numbering starts at the carbon atom with the halogen atom. If there's only one, then you don't even need a number. Name and number any alkyl Sally groups on the main chain. Insert the number of carbon atoms bonded to the halogens. Okay, use the prefixes. So for chlorine, you would use chloro, fluorine would be fluoro, bromine would be bromo, and iodine would be iodo. Okay, if there are 2 or more of the same halogen, use the prefix to indicate their numbers. So if there's 2 chlorine, it'd be dichloro, okay, or trichloro, or whatever it is. Okay, if there's more than one halogen present, you write them alphabetically, again, not including these prefixes. So bromo would be the first one, then chloro, then fluoro, then iodo. Okay, and then, yeah, any prefixes are not considered. Okay, and so some examples here. So name the following. So again, first thing you want to do, count up the parent chain. This bromine should be over there. Not sure what's wrong. Okay, so we have 1, 2, 3, 4, 5, 6, 6-carbon chain. Again, we want the lowest number, so we're going to start numbering from this side. So this would be carbon 1, carbon 2, 3, 4. So we start with bromo because it comes before alphabetically before chloro. So we'd say this is 2,4 dibromo 3-chlorohexane. Okay, and then this next one, again, count up the parent chain. So we have 6 carbons, so a hexagon. Okay, we have bromo groups coming off. We want the lowest possible number, so this would be 1, 2, 3, and then the methyl group would be carbon 4. If we went the other way, 1, 2, 3, 4, 5. And we have to start always with a bromo group because it comes first. So even like this would be 1, 2, 3, 4. And so we're going to start here. So it'd be 1,3-dibromo 4-methyl cyclohexane, okay, which it shows down here. Okay, so some practice with these. Okay, so draw the structural formula. So again, when we're drawing them, okay, start with your chain. Okay, so we always look over here. What is our parent chain? So it's hexane. Okay, so we're going to start with a 6-carbon chain. So 1, 2, 3, 4, 5, 6. So we have our 6-carbon chain. Okay, now we can fill it in. So we have, coming off our 2nd carbon, we have a bromo group. Okay, we have 2 bromo groups coming off that 2nd carbon. Okay, so there, and then off our 5th carbons is another bromo group. Okay, and then off our 5th carbon is also a methyl group. Okay. I'm going to draw the condensed structural formula, even though it asks for structural. Just again, be careful when you're doing assignments. Make sure you do the one that's asked for. Okay, and so for this one, I'll put the H3 over here just so it fits. Okay, this one has 4 carbons or 4 bonds already, so it's done. So we need 2 more H's here. We need 2 more H's here. This has 4 bonds and then 3 more there. So that would be our condensed structural formula for 2,2,5-tribromo 5-methyl hexane. Okay, for naming, okay, again, like, so we'll start on this side. So this is carbon 1, 2, 3, whoops, that's a mess, 4, 5, 6, 7. So we have a 7-carbon chain. Okay, we have coming off our 2nd carbon, a bromo group. So we're going to go 2 bromo, 4 chloro, heptane. Okay. Again, if you want more examples, just let me know and I can do a separate video just doing examples. Okay, now we're into alcohols. Okay, so an alcohol is a hydrocarbon derivative that contains our OH group or a hydroxyl functional group. One thing that not to confuse them with is a hydroxyl group is a OH branch coming off of it. Okay, it's a molecular. Okay, where the name of the ion with hydrogen and oxygen is a hydroxide ion. This is something different. This is only in ionic compounds. And again, anything with ionic, now that cancels out. If it's ionic, it's no longer an organic compound. Okay, so some common alcohols and their use. So the first one would be methanol. Okay, so again, as we see here, it has 1 carbon, so meth, and then the OH group coming off, so methanol. Okay, so it's wood alcohol, methyl alcohol are some common names for it. It's a solvent used in many chemical processes. It's compound or component of antifreeze in our automobile, also used in fuel. Okay, ethanol is a grain alcohol or ethyl alcohol, or its names. Okay, the solvent in many chemical processes, it's the component like in alcoholic beverages. It's an antiseptic liquid and additive for fuel. Propan 2-ol, this is our rubbing alcohol or isopropyl alcohol. Okay, and so it's antiseptic liquid. And then ethane 1,2-diol. Okay, so another component in automobile antifreeze. So that's again like just because it says alcohol, there's really only one alcohol that is drinkable. Even then, only in small amounts. Okay, and so the rest of these would be harmful. Okay, one thing to notice too is the boiling points. Okay, what happens to boiling points with, like, again, if we think of methane, it's a gas at room temperature. Okay, but methanol has a boiling point of 64.6. So because of this OH group, its boiling point goes way up. And so the boiling point goes up because of the hydrogen bonding happening in our OH hydroxyl group. Okay, so naming and drawing alcohols. So the root name of the alcohol is based on the parent alkane, which is the alkane with the same basic carbon structure. So basically, again, you're finding the longest chain that includes the hydroxyl group. Okay, and name that parent chain. Okay, the suffix will always end in OL, so your ending, like your last two letters of alcohols will be OL. Okay, the position of the hydroxyl group is indicated with a number in front of the OL. So if you see here, like as soon as there's only one spot to put it for the first two. After that, we always have to say where it's coming off of. Okay, and then the numbering of the carbon chain begins with the carbon atom at the end of the chain nearest to the hydroxyl group. So again, this takes precedence kind of over any other like methyl group or anything like that. If there's a hydroxyl group, you're going to have the numbering lowest to that hydroxyl group. Okay, again, if there's more than one hydroxyl group, you'll use the di, tri, tetra to indicate how many hydroxyl groups. Okay, a number for each hydroxyl group is placed at the beginning of the suffix. So if you have more than one, so as we see here, we have ethane, 1, 2, there's two of them, so diol. Okay, if the suffix begins with a vowel, we drop the E on the end of the parent chain, so like mono alcohols. Okay, that's where like here. So if the suffix, begins with a vowel, so here's our vowel here on our suffix, so we drop the E. Okay, here we have a consonant, so we don't drop the E. Okay, and then identify the prefix, name, and number any alkyl side group. So that comes after you've named your alcohol. You add those prefixes to say. Okay, so for this one, if we're writing a IUPAC name for this alcohol, so we see here's our hydroxyl group. Okay, so we're going to start a number on this side. So 1, 2, 3, 4. Okay, and so we'll start with, so it's going to be bute. Okay, and again, because we only have one, then we don't have to, like, we take the E off here. So butan, okay, it's coming off the second carbon, so 2, and then all. Butan 2-ol. Okay, now we have a methyl group, so we add that in, so we got 3 methyl. Okay, butan 2-ol. So here it is down there. Okay, and then you should be able to know like some of their physical and chemical properties. Okay, so look those up there in your textbook. Okay, and then like be able to write down any of their formulas. Okay, with alcohols, sometimes we can have more than one hydroxyl group. Okay, and so we can kind of characterize are different types of alcohols in the primary, secondary, and tertiary alcohols. So primary alcohol, okay, so to 1 degree, carbon atom, or the carbon atom carrying the hydroxyl group is bonded to one other carbon atom. So as we see here, okay, so this carbon atom that's bonded, we're always looking at what it's bonded to. Okay, so it's only bonded to one other carbon atom. Okay, so this is our primary alcohol. So I guess it doesn't have, these ones don't have to do with how many hydroxyl groups. Sorry, I misspoke there. These have to do with how many carbons, okay, our carbon that's bonded to our hydroxyl group. That's what it has to do. So carbon carrying the hydroxyl group is bonded to 2 other carbon atoms. So this one here is bonded to 2 other carbon atoms. So it's a secondary alcohol. And then a tertiary alcohol, the carbon that's bonded to our OH is bonded to 1, 2, 3 other carbons. Okay, for naming the following alcohol from its condensed structural formula and then indicate whether it's primary, tertiary, or secondary. So this one, so again, find the longest chain. So we have a 5 carbon chain. Okay, we have our hydroxyl group coming off the second carbon. Okay, so we can write it down. Okay, so we have pent. That's not pentan. Sorry, this is not writing as well. Pentan. Okay, it's coming off the second carbon is our hydroxyl group, so 2 all, and then we can say our prefix is going to be 2-methyl. So 2-methyl pentan 2 all. Okay, this next one. Okay, let's name it. Oh, and this one, sorry, wanted to say primary, secondary, tertiary. This one, so again, this is the carbon that's bonded to the OH. Now we look here, it's bonded to 1, 2, 3 other carbons. So this is, I'll just circle this. This is a tertiary alcohol. Okay, for this one, naming it. Okay, so again, we want our longest chain connected to our OH. So we have a 4 carbon chain, so it's going to be butan, but, and 2 all again. We have 2 methyl groups coming, so it's going to be, they're coming off carbons 2 and 3, so 2, 3 dimethyl. Okay, 2, 3 dimethyl butan 2 all. It would be the name, and if we were saying again like tertiary or primary, secondary, tertiary, again this is the carbon that the OH is coming off. It's bonded to 1, 2, 3 carbons, so it's another tertiary alcohol. Okay, and with alcohols, they can contain more than 1 hydroxyl group, so you just have to indicate in the name if they have more than 1. So like for this one, ethane 1, 2 diol, propane 1, 2, 3 triol. Okay, and so if we're drawing the structure, butane 1, 3 diol, so we draw butane, so 4 carbon chain. Okay, coming off the first and third carbon are our hydroxyl groups, and then we fill in all of our H's. Oops. So that every carbon has 4 bonds. This time I'm just going to put H3. Okay. For cyclic and aromatic alcohols, so aromatic again has benzene. Okay, we draw our cyclic molecules. So in this one, like C6H12OH, okay, is cyclohexanol. Okay, because cyclohexane would be C6H12. Okay, but then we take out an H and add this OH. Okay, phenol, okay, is again C6H5 is benzene. Okay, we take out one of the H's and add in the OH, so that's why we get instead of benzene. Okay, when you're using benzene as a branch, we called it phenyl, like a YL. Okay, but now with the OH, we call it phenyl or phenol. Okay, with the OL. Okay, and then if we're drawing a line structure, okay, remember, so like for cyclopentane, we have our cyclopentane here, and then two hydroxyl groups coming off of it.